Hello everyone, and welcome back to the Fluctus channel. In the past few decades, the aviation industry have suffered an increase in weather-related flight cancellation, which includes heavy snow or blizzards. Sub-zero temperatures are not only a problem to humans, but also pose great dangers to the airport operation and the aircraft itself. Hence, various systems are put in place to mitigate the risks of operating in such environments. Ice buildup on an aircraft can be fatal since it alters airflow on the wings and tail, thereby reducing the lift force that keeps the plane in the air. This can cause aerodynamic stall, a condition that can lead to a temporary or fatal loss of control. Extremely cold temperatures can even cause the engine to stall, which is why planes are typically de-iced when temperatures fall below 30 degrees Fahrenheit. The process begins with the aircraft being inspected for signs of contaminants adhering to surfaces. It is also checked for snow, ice, frozen and semi-frozen moisture on the frame and engine of the aircraft. If contaminants are found on the airframe surfaces before the time of expected takeoff, then the de-icing team of icemen are called in. They apply a suitable anti-icing substance on the aircraft through high-pressure spraying from specialized de-icing trucks. These trucks are fully equipped, including cranes, from where a bucket man is suspended to access the higher parts of the aircraft. They do the job very meticulously to avoid damaging the aircraft.
We have to have our head on a swivel. We have to be aware of everything. We have to be aware of how close the front end of the truck is to the engine, to the fuselage, how close the back end is to the fuselage of the engine when we're swinging down the leading edge of the front wing or the horizontal or vertical stabilizers.
The spray contains a special mixture of glycol and water, a substance with lower freezing temperatures than water alone. This substance clears ice, snow, and frost easily and can delay any further ice buildup between 45 to 90 minutes. Apart from commercial planes, military aircraft are also regularly de-iced whenever freezing temperatures hit an Air Force base. This process prevents missions from being delayed or postponed despite bad weather. Specially assigned airmen from the squadron make sure mission priority aircraft are properly de-iced before they are rolled out for takeoff. During this process, accumulated ice on the wings, propellers, and windshield are melted off before the plane rolls to the runway.
We heat that in the truck to 185 degrees, and then we spray the aircraft with that. That'll help melt off any more ice that's left behind or any snow that just won't leave. Then once it melts it off, we can just blow the big chunks off with the hot air. Smooth operation, all environmentally safe, and the people are safe because they're inside out of the noise.
In some cases, it is not the airplane but the runways that get clogged with snow and ice, which makes takeoff and landing become virtually impossible. At the Václav Havel Airport in Prague, for instance, the airport has only one entry and exit permitted. Therefore, it has to ensure extremely quick clearing of snowfall over its 12,000 feet long runway. The snowplow convoy at work there does the job in one single pass, which sometimes lasts just 30 minutes. The convoy consists of 13 plow blowers and 2 dispersing machines. A control vehicle circles the convoy operation to oversee the entire operation. In case of a heavier snowfall, 2 additional high-capacity snowblowers are called in for backup. Once airborne, the pilots often have to fly through bad weather systems, which pilots try to avoid as much as possible. Windy storms and jet streams increase flight turbulence, causing the plane to roll and pitch uncontrollably. Severe turbulence hinders the smooth flow of air, which in turn decreases the ability of the airfoil to create lift. During turbulence, lightning strikes also constitute a danger to aircraft. Severe lightning strikes have the potential to cause a short circuit in the plane's avionics or cause structural damage to the plane's exterior. They are built with a thick exterior metal containing shields and suppressors that prevent a lightning strike's electromagnetic energy from penetrating the interior of the aircraft. In the USA, all vital components of the plane must meet the Federal Aviation Administration's safety regulations. And furthermore, all planes hit by lightning are subjected to rigorous inspections after landing. Planes are also equipped with weather monitoring radar systems through which pilots can detect thunderstorms in advance and avoid flying into them.
About 50 miles ahead. The storms and the red bits are very turbulent. Green is mostly rain. The yellow can be a little bit bumpy, but certainly the red bits are quite turbulent and you want to avoid that.
Weather and storms aside, some airports are extremely challenging for landing on any day. Lukla Airport in Nepal is known to be one of the world's most challenging airports for pilots. To land at Lukla, pilots must be very skilled in short takeoff and landing flights with prior experience in near similar landing situations. The Lukla Airport is an asphalt strip measuring only 1,729 feet in length instead of the 6,000 feet ideal length. The strip has a steep 10-degree incline and is completely enclosed by the mountains at one end. Thus, landing is done in only one direction with no circuit. Lukla somehow shares this uniqueness with the Paro International Airport in Bhutan, though having a standard runway over 6,000 feet. This airport is located deep in a valley surrounded by Himalayan mountain peaks as high as 1,800 feet. Said to be the most dangerous in the world, landing at Paro Airport is so tricky that fewer than 20 pilots in the world are qualified to land there. The pilot needs to watch out for electrical poles and house roofs on the towering hillsides as they maneuver between the mountains at a 45-degree angle before dropping quickly onto the runway. From bad weather to tricky runways, airline operators and airport authorities are constantly working hard at finding cost-effective, safe and efficient ways to make air travel in any condition and climate easier and safer for everyone.